Hello, welcome back. Today we shall explore Rolle's theorem. It's usually one of the beginning chapters in any calculus introduction class, and we're going to explain what it does and where it actually comes from. Well, what Rolle's theorem actually states is that if we have some graph, I'm only going to draw the first quadrant, and let's say it looks like some type of parabola. And this we're going to call point A, and this we're going to call point B. But it pretty much states that if the function, we're going to call it f, at A has some value up here, and the function at B has the same value, then we can conclude that at some point the slope is going to be 0. Alright, well at first you might say, oh, well, I wonder why. Let me just memorize it. What? But it's very it's a very important formula and actually helps you derive many things. Well, in this case, we're just going to concentrate on where it comes from. Well, we're just going to think about this. To get from point A to point B, you see that there's literally no change. The only change is the x value change. Only the x changed. The y couldn't change at all. So, in a way, if you look at it graphically, you can actually see that there has to be actually a point in between A and B in which the derivative equals 0. Because remember, derivative equals 0 means that you have a horizontal line, like we see right there. And from A to B, we also have a horizontal line. So if we, in this case, this is called the secant line from A to B. And then when you actually match it up to the function, you always find a point in the function. But remember, there are some qualifications needed for this theorem to exist. The first one is continuity. Continuity is very important because the Rolle's theorem works is because you assume that the function is going to go up, and because A and B are the same, it has to come down. And for it to come down, it has to go through all these y values from here to here. Now, for example, if we had something a little bit more to the extreme, such as the following. Let's say we had vertical asymptote here. Obviously, this is not continuous, and now we can't apply Rolle's theorem. Why? Because although A and B, right here, are at the same value, we'll assume they're the same value. The Rolle's theorem cannot apply because it's not continuous. Here, if you see the function going up, 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 usually it has to come down. But boom, it just disappears, and then it appears from negative infinity, and then it continues its trajectory. This tells us that it's not going through a traditional pathway. In other words, because it's not continuous, Rolle's theorem does not apply.